Welcome to Full Spectrum Science. I'm your host, Ron Hipschman. Today, we're going to talk about Pi Day. This is the 36th annual Pi Day, and also Einstein's birthday. Did you know that Pi Day was invented 36 years ago at the Exploratorium? We take the whole idea of Einstein's famous tongue photo very seriously on Pi Day, and so do the Swiss. In 2020, the state-owned Swiss Mint issued a 3-millimeter, 1/8 inch diameter gold coin with Albert Einstein's face on it. It's the smallest gold coin in the world with a face value of 1/4 Swiss franc, or about 26 cents. Unfortunately, only 999 were made, and they were sold for 199 francs, or about $70, with a special magnifying glass so owners can see the famous physicist on its face. Even though we have the Swiss consulate over at Pier 17, I was not able to obtain one. Your favorite pet can't resist emulating Einstein, or one of my fellow staff members' kids, nor could my very good friend and astronomy professor Benjamin with his longest COVID hair. Or our very own Larry Shaw, the founder and inventor of Pi Day way back in 1988. This day is a tribute to him and his life. Pi Day has a nice Wikipedia page, and there you can see our Prince of Pi, Larry Shaw. Please support Wikipedia. Larry built and placed the original Pi shrine on the mezzanine of the Exploratorium back when it was at the Palace of Fine Arts. He placed it in the middle of the round classroom made of round cinder blocks. A very appropriate place, I think you'll agree. When we moved to Pier 15, we dedicated a new Pi shrine on the public plaza in front of the museum on the Embarcadero. Be sure to visit it and walk around it 3.14 times in celebration. We celebrate Pi Day on March 14th at 1:59 p.m. Reduce it to its numbers, and that would be 3:14 at 1:59. Remove all those extraneous symbols, and you get the value of pi, 3.14159, or at least an approximation. Sometimes we celebrate 2 Pi Day on June 28th at 3:18, or 6/28 at 3:18. 2 times pi is 6.28318. And occasionally, when we're feeling silly, we celebrate 3 Pi Day. 3 times pi is 9.424778, which would occur on 9/42 or September 42nd, or really October 12th if you carry those extra days from September. In Europe, they write the date as day month, so they're limited to celebrating Pi Approximation Day on July 22nd or 22/7. You may remember that 22 divided by 7 is a good approximation of pi, and indeed it is, 3.14285, good to 0.04%. One of the most common places where pi shows up is in the famous formula for calculating the circumference of a circle if you know the diameter. The circumference, or how far around, is equal to pi times the diameter, or how far across, or in shorthand, c equals pi times d. By moving things around algebraically, we can see that pi is the ratio of the circumference to the diameter, and this is true for every circle, no matter its size. For instance, if we start with this lovely pizza and some pepperoni, you'll notice that in this case, 7 pepperoni fit across the pizza. Well, if it's 7 pepperoni across, you'd also notice that it's 22 pepperoni around. The ratio of the circumference to the diameter here is 22 pepperoni around to 7 pepperoni across. Remember that 22/7 is a good approximation for pi, at least to 0.04%, which is good enough for pizza. Here you see it again. And again, it's the same for all circles. Pi is irrational. That means a few things. First, it cannot be written as the ratio of two integers, like our pi approximation 22/7. That's a ratio of two integers. Next, it has to have an infinite number of digits. Our approximation does have an infinite number of digits, but it fails a third test, that it does not settle into an infinitely repeating pattern of digits. Here, you can see the repeating pattern of our approximation. Pi never repeats. You may have heard that pi is also a transcendental number. This is a bit more complicated to explain, so briefly, a transcendental number cannot be calculated with any finite series of algebraic operations. Every transcendental number is also irrational. Let's just move on. Pi has a long and storied history. If you look at the Wikipedia's list of the chronology of the computation of pi, you'll find 112 record-breaking computations. We don't have time to explore all of them, so let's take a quick look at some selected bits. Notice how important pi was to so many cultures. In Egypt, around 2600 BCE, a long time ago, they used our 22 divided by 7 approximation of pi. That got them quite far. 700 years later, in Babylonia, around 1900 BCE, they were using 25/8 as a reasonable approximation, only 0.5% too small. 1,300 years later, at the time the Bible was written, around 600 BCE, we find a value of pi in the text of Kings chapter 7. And he, Hiram, made a molten sea, 10 cubits, from one rim to the other it was round all about, and a line of 30 cubits did compass it round about. Okay, 10 cubits in diameter, 30 cubits around. That gives us a value of pi equal to 3. We're losing some accuracy here, but we're still within about 5%. Archimedes came up with a brilliant geometrical method to calculate pi about 400 years later. He used polygons. He could accurately calculate the area of any polygon because you can break it up into triangles, and it's easy to calculate the area of a triangle. Now, Archimedes drew a circle so that it just fit inside this polygon, and another similar polygon that just fits inside the circle. Archimedes understood that the area of the circle falls somewhere in between the areas of the bigger and smaller polygons. Remember that the area of a circle is pi times the radius squared. If he could figure out the area, he could figure out the value of pi. Archimedes also determined that the more sides the polygon has, the closer the areas of the two polygons approach the area of the circle. With many, many sides, you can narrow down the value of pi. Archimedes used a 96-sided polygon and calculated the value of pi to be between 3.141 and 3.143. Not bad. Moving to China, Zhang Heng in 130 AD declared that pi was the square root of 10, good to 0.1%. He got a postage stamp, eventually, for his efforts. In India, Madhava of Sangamagrama in 1400 AD calculated pi to 11 digits. Now we're getting some real accuracy. In Persia, present-day Iran, Jamshid al-Kashi in 1424 calculated pi to 16 digits. He also got a postage stamp, eventually, for his efforts. Ludolf von Keulen, a German-Dutch mathematician, spent most of his life calculating pi to 35 digits, using essentially the same method as Archimedes, except Ludolf didn't stop with a 96-sided polygon. His had 2 to the 62 power, or 4.6 quintillion sides. Incidentally, 35 digits of pi is way more than enough to calculate anything anyone could possibly use. More on that later. After his death, the Ludolphine number, pi, was engraved on his tombstone in Leiden. The tombstone was unfortunately lost, but later restored in the year 2000, which is what you see here. The first to use the Greek letter pi as a symbol for the number was William Jones in 1706. He took the first letter from the Greek word perimetros, meaning perimeter. But back to our calculations. In 1853, William Shanks performed the largest hand-done calculation to date. In 1853, he published 527 digits of pi. 20 years later, in 1873, after much more calculation, he expanded his accuracy to 707 digits. But unfortunately, because of an error at the very beginning of his calculation, only the first 528 were still correct. Even though that meant 20 years of hard work down the drain, it was still a magnificent achievement. John von Neumann, in 1949, found 2,037 digits with a calculation that took 70 hours of computer time, not 20 years of his life, and he did it on the ENIAC computer. The ENIAC, or Electronic Numerical Integrator and Computer, was the first programmable electronic general-purpose digital computer. By the way, a modern iPhone has 4 processors that each run over 640,000 times faster than ENIAC. But I digress. In 1958, François Janouille calculated pi to 10,000 digits in 1.7 hours on an IBM 704 computer. In the modern era, 1 million digits were first calculated in 1973, a billion digits in 1989, 1.2 trillion digits in 2002, 2.7 trillion in 2009, 13 trillion in 2014, and 22 trillion in 2016. For the next two, I just want to point out a couple of recent personalities of pi computation. On Pi Day 2019, Emma Haruka Iwao and the pi calculating team at Google computed pi to 31.4 trillion digits. And on January 29, 2020, Timothy Mulliken, on a computer he built himself, calculated pi to 50 trillion digits. His calculation took 303 days at a cost of about $10,000, which was only 5% of Google's $200,000 cost of calculation. Adding Emma and Timothy to the list doesn't quite complete it, however. In 2021, a Swiss team calculated pi to over 62 trillion digits, and just last year, pi was calculated to 100 trillion digits, again by Emma Haruka Iwao and the Google team. I want you to notice something here before we move on. Look carefully at Emma's 2019 calculation. Notice anything familiar? It's the value of pi in there. Pi times 10 to the 13th power digits. And the 2021 Swiss value is double that. 2 pi times 10 to the 13th power digits. All in all, that's a lot of pi. If we plot the number of digits calculated through time, here's what we get. Note the vertical scale is logarithmic, meaning for each vertical square you multiply the digits by 100. Up until about 1950, the number of calculated digits grew rather slowly because all that work had to be done by hand. After 1950, the digital computer sped things up tremendously. 100 trillion digits of pi is a lot of digits. How many do we really need? Voyager 1, launched in 1977, is the farthest human-made object from Earth and the first spacecraft to reach interstellar space. It's about 14.8 billion miles away, moving almost 38,000 miles per hour. NASA uses 15 digits of pi to calculate spacecraft positions. 15 digits gives us an accuracy of plus or minus 1.5 inches in Voyager's position. Remember that Jamshid al-Kashi calculated pi to 17 digits in 1424. Here's another example. Take the entire universe. We have a pretty good figure for the diameter of the known universe. Let's say we wanted to calculate the circumference of the universe to an accuracy of plus or minus the diameter of a hydrogen atom. The hydrogen atom is really small, 53 picometers in diameter, 53 trillionths of a meter. How many digits of pi would we need to get this accuracy? Using our now familiar formula, we'd need only 39 digits of pi. Pi Day has found its way into popular culture. It was first declared National Pi Day by an act of Congress in 2009. Let's take a listen.
House Resolution 224, resolution supporting the designation of Pi Day and for other purposes.
On this vote, the yeas are 391, the nays 10. Two-thirds being in the affirmative, the rules are suspended. The resolution is agreed to.
What I want to know is who would vote no against Pi Day? Aside from Pi Day, pi has found its way into popular culture in Hollywood, too. In this episode of Star Trek, an alien being has invaded the computer of the Enterprise. Spock has a way to keep it busy.
Ready.
Implement.
Computer, this is a Class A compulsory directive.
Compute to the last digit the value of pi. As we know, the value of pi is a transcendental figure without resolution. The computer banks will work on this problem
To the exclusion of all else until we order it to stop.
Yes, that should keep that thing busy for a while.
There was also a rather disturbing movie, Pi, made in 1998. A popular activity involving pi is seeing how many digits one can memorize. The current record holder is Rajesh Meena, who recited 70,000 digits. 9 years before that, in 2006, Akira Haraguchi, a retired Japanese engineer, claimed to have recited 100,000 decimal places, but the claim was not verified by Guinness World Records. What tricks can you use to remember pi? A useful trick, called pi philology, or Pilish, is to make up a piece of text where the number of letters in each word help you remember the digits of pi. Here's a sentence that will help you remember pi to a NASA accuracy of 15 digits. Notice the number of characters in each word. How I need a drink, alcoholic in nature, after the heavy lectures involving quantum mechanics. This is a form of what's called constrained writing. Mike Keith is a friend of the Exploratorium and a master of constrained writing. He paraphrased Edgar Allan Poe's The Raven to use the first 740 digits of pi. This is also called a Piem, but this was just the beginning. Here's Mike in front of his computer with the first 1,000 digits of pi. Mike also wrote an entire book, Not Awake, where the words use the first 10,000 digits of pi in all kinds of writing styles. You can get this book online if you want your own copy. Of course, stealing the form of haiku, a paiku has the familiar 575 syllable form, but about pi. Here's Paul Doherty's entry. A circumference. Divide by diameter. Irrational pi. One from Robert Foss. Pi Day's my birthday. Can I get free admission? Spent my cash on rent. And one last one from our own Ken Finn. Best pizza value can be found with this number. Make mine with mushrooms. And of course there are limericks. If inside a circle a line hits the center and goes spine to spine, and the line's length is d, the circumference will be d times 3.14159. Now you too will begin seeing pi everywhere, like these M&Ms I found. Those aren't incomplete M's, they're obviously pies. From the entire staff of the Exploratorium, including Larry Shaw, the founder of Pi Day, we'd like to wish you all a happy Pi Day.